All right, welcome back from the coffee break. The coffee break was too short, right? It was way too short. And this is why I will move away from the stage in any second, because I will give you in the good hands of Benedikt Stemmildt, CTO at TalentFormation, for the next slot, which is called From Search Results to Insights, Learnings from Statista's Generative AI Journey. Have fun.
Thank you very much. Hello, everybody. I'm super happy to be here on stage again. Thank you so much for joining us. We have brought a very special topic for today's presentation because we are talking about AI. So you probably haven't heard any talk about AI in the recent months. So it's the first one. Yeah, I bet. But we will do this a little bit differently because we have brought something real from production and not something that someone is tinkering in his basement. So this is like a real project that you can all also use and already feel. And you will learn a lot about optimizing an AI system for real-world production usage in this talk. But first of all, let me introduce the speakers and why we are here and why we are three people. Today we have Ingo. Ingo is the CTO of Statista. He's our client, our customer interaction. He's representing Statista and built the initial product with his teams, and then came to us to ask for help to optimize it so that we can run it and test it in a real world with real customers. And then we have Matti. Matti is the CTO and founder of Heureka Labs, and he's the one who built and optimized the product for using it in production. And I am Benedikt. I'm the CTO of TalentFormation, and I was the one who brought them together, right? So that's why we chose this trio there. I'm the one in the background. Matti is the genius, and Ingo is the one who's with both feet on the ground and having the real customer and real life in the vision. Before talking too long about us, I would say that I hand it over to Ingo to introduce to you Statista and why you actually came to us, why it actually has relevance and matters for you. Thank you so much and have fun.
Thank you, Bene. As Bene pointed out, we want to share real-life experience, and I want to share some words about the context. I want to share some words about Statista, the company, about our platform that we are building, and it's also important to understand some of the context of the user journey before diving into the solution we actually conceived for our customers. Now, Statista, you may know it, it's today already 17 years old, so almost a mature startup. We have a customer base grown in different countries. Largest business is US, but also Japan, UK, Germany, France are large companies. So we are, for a Hamburg-based company, very global and proud of that, serving about 30,000 paying customers in those countries from various industries. Users or customers buy us because they need support for marketing, entry studies, for pitch decks, and so on. You may have used it from time to time. We also serve academia clients, and they all work on the same platform. You know our web platform, maybe. It is actually quite a simple platform, and simplicity is also a core value of our platform. We want to be a general purpose product. We are not the ones that answer the latest question of, for instance, the marketing experience. We don't have data on SKU level per shelf, per outlet on retail brands. This is not what we are having. There are other providers there who have that. What we do have is a very comprehensive overview with millions of statistics across various topics and industries and also countries. So the simplicity is important, trustworthiness is important, so all our data are curated by 300 to 400 researchers and analysts that are checking sources, that are providing context and explaining the data you have to make it really easy to digest the data. And you can imagine that the core of our platform is the discovery of finding the right data. If you have millions of data, that's like a job marketplace where you have millions of jobs, but you don't find the one that you actually need, right? I had those questions in my previous company. Here it's likely the same, right? You can have your question, but if you don't find the statistics you really need, you don't care about the million other statistics. So discovery is a core challenge for the user experience. Now, some numbers, if you see that, just to give you a glimpse of, for the later discussion of what we had to tackle, it's 1 million statistics we are talking about. We have about 70,000 reports, that is comprehensive multi-page reports with text and data. And this is highly used. We have about 23 million users or views per month and about 500,000 downloads of the more complex data. And a lot of our traffic is building on organic traffic. I'll come to that in a second. And we are very proud that we are already on rank 131 in the Majestic Million before Time magazine. That's where we are very proud of. Now, why is that relevant? Because it's a major part of our user journey. In the essence, the user wants to find the data they are looking for. That is the statistics. It's very plain and simple. It's a title, it's a group of data, and it's an explanation, coming with sources, publication date, and so on. That's quite simple. You always also find the third-party source, if applicable. You also find the researcher who did the quality assurance. Obviously, we do have a search function, as you saw, and that is one means to find the data you're looking for. There's also a navigation scheme. But the majority of our users are coming from organic traffic. So, and that's mostly Google, actually. So depending on whether you look at paying customers or logged out traffic, it's 66 to 80% of our traffic coming there. And that is the user journey which is relevant for Statista customers. Now, early 2023, there was a major shakeup with ChatGPT entering the scene, right? And I remember quite vividly that we discussed, wow, this sounds having a lot of impact on what we are doing. It's a completely different level of accessing information and digesting information. And we were obviously wondering, how is that relevant for us? We did see the capabilities coming with LLM, providing completely new experiences for our users, but we also saw the threats that we are easily intermediated. Why would you go to Statista if ChatGPT already provides quite a good answer? There was, on the other hand, quite some confidence that we knew the strength of our brand, and we knew that paying customers are paying because they want this trusted source. They don't do a screenshot of some Google research for professional purposes, but they want to have a professional source. So there was also some strength we could build on. The weakness was we had no clue whatsoever regarding generative AI. And that is where Matti and his team came in. But before Matti came in, the journey started even in smaller steps. As I said, it was about February 2023 when we discussed in the XCOM, wow, we need to find our way to treat generative AI opportunities. And the first thing we did is that we said, we will not find out from a management perspective, we need to find out from a technical perspective what is feasible, explore different use cases. And we started with the very simple decision to dedicate one engineer, freeing him up from any other tasks he had, who was very close at least to generative AI. He had a mathematics background, was an engineer, and he was given full flexibility to explore all options that were feasible. And basically he left us for 2 months in his home office, exploring all use cases, talking to a lot of people. And then after 2 months, he came back and said, look, Ingo, here's 3-4 use cases I have. I guess this is the one we should pursue. And we quickly agreed that this is the use case which had the most potential and where we would like to develop a prototype that we can take to management. We did that, and mid of last year, we were seeing a prototype which proved the principle. It was not nice, it was not scaling, it didn't include all data sources we had, but it showed the proof of principle, and we decided to go into product development mode. So we added a product manager, but obviously we didn't have internal resources that had the required skills to start real production work. And that is where Matti came to us, mediated by Bene, and Matti will tell you a bit about the journey, about what he found when he came to us, and how he helped us to get ready for production. Matti.
So to go into production, of course, the application should be nice and fast and not too expensive. So when we tried out the first prototype or proof of concept, it showed that it was a good idea. It worked most of the time, or sometimes we are not sure. It was kind of slow. It was expensive. So it was not clear if it's really production ready. So let's talk about optimizing such systems. At first, of course, we looked at the application itself. And it's a very typical RAG application. So RAG stands for Retrieval-Augmented Generation. So you have a lot of data you want to use. You cannot put all the data just in one request to a large language model. It's too much. So you have to select some of the data, in this case statistics. And you do this by putting all your data in a vector store and retrieve semantically similar documents, or statistics in this case. So user asks the question, and in the first step, I'm doing a retrieval. So I'm looking up similar statistics that could help me creating the answer. Then I normally have a re-ranking step, so just sort them by relevance to get the most important statistics, and then generate an answer. And this is, of course, the magic here. Like, I don't want to show search results anymore. I have a technology now that could really directly deliver the answer to your question. And then we're doing a rating in the end to judge whether the answer is good enough to show it to the user, because we don't want to deliver a bad answer. This is the overall structure. And we looked at the code, and we figured out quite fast there were a lot of large language model calls in there, 42 in the end. So there were 40 large language model calls to an OpenAI model for the re-ranking. We retrieved 40 documents, asked for each document whether it's relevant or not, and then one for answering, one for the rating. So we directly figured out the biggest quick win ever. Like, it's okay, this is the project about. We will leverage this application in no time. But before changing anything, we added traceability. And this is the first thing you should always do. Like, understand what the application is actually doing in every single granular step. What is actually sent to the large language model? How fast or slow is which step? How expensive is which step? And when we broke this down, we figured out like the re-ranking with the 40 calls is about 5% of the latency and about 13% of the costs. So it's really not an issue. Latency is mostly in the retrieval, of course, a lot of data, similarity search, and within the answering. Costs are mainly about in the answering. So you need traceability to get an idea of what the actual issues are and to prioritize them. And now, with this out of our mind, we needed to talk about the metrics. Like, what is even relevant? It's mostly about quality, about latency, about costs, but you need to bring them in an absolute order. Like, which is the most important part, followed by which one? And if possible, define some kind of thresholds to just give you some kind of guidance what techniques could be used and what techniques doesn't make sense for your use case. So in our case, for example, quality is the most important thing for Statista, followed by cost, followed by latency. We defined the thresholds of below 5 cents for the costs and below 30 seconds for the latency on average. With these metrics, we could measure the latency, we could measure the costs, but what about the quality? We need some kind of quality metric. And to define a quality metric, you need a reference data set. You need some kind of ground truth. So you need to define, like, when I ask this question to the system, what is my expected answer? Now, Statista has a lot of content experts, so we have the opportunity to come up with a reference data set we could test on, and then just look how good does our system perform. When you have a reference data set, of course, you need to measure it. What we could do, we just take the actual answer from our system, we take the reference answer, and we just ask a large language model, how good is this answer? It's often called large language model as a judge. This is the technique we use as well to come up with a quality metric. And then we just implemented a small test runner that could create those 3 metrics as easy as possible on a button press, because we wanted to just do small changes and measure the effect in our metrics. And this is the baseline we came up. So when we finally set up all the metrics, we figured out on average, our system takes nearly 30 seconds to answer. It's more than 8 cents of costs, and the quality is 30%. So definitely a lot of potential for improvement. So here we had it like black on white, it's not production ready yet, we need to optimize. But we were set up for optimization, so we could make a lot of experiments. We executed more than 100 experiments with different techniques to measure the effect on our current system. It's very hard currently to have an intuition on the techniques because they're quite complicated. It really depends on the data, on the actual questions. So you really need to try it out, and you need a setup that it's as easy as possible to try it out. This is where we ended. So we improved the latency by 10%. We actually improved it by 65% and then reinvested the time in the more slower techniques. We improved the costs by 65%, and we increased quality by 140%. And this is the most important part for the project. And this was done in only 3 weeks. So after the setup, we had 3 weeks of pure experimentation to come up with these improvements. So just to recap our like a playbook for optimization, you need tracing. You need to define your metrics relevance. You need a reference data set. You define your baseline or measure your baseline, and then you do experiments to just improve the overall system. So let's talk about learnings, what we learn on our way. And the main learning is about this similarity search or similarity lookup, because it's the core of every RAG system. You need you're taking the query from the user and you look up relevant statistics or documents in general. But why should like a statistics snippet be similar to some random user query? Like if you think about it, it doesn't necessarily make sense that the semantics are similar when on the one side there's like the answer capsuled in a lot of data and statistic or interview or whatever, and on the other hand you have a random user query. So we need some kind of pre-processing. And this was the main focus of our experiments. Like the easiest thing you could do, just ask a large language model to come up with a better query. To just to come up with better wording, remove irrelevant information. So for example, how tall is the Eiffel Tower? It looked so high when I was there last year. Just rewrite it to what's the height of the Eiffel Tower. This will perhaps provide better answers. Overall, we couldn't see a real big quality improvement. We saw the answers changed a lot. So some tests broke that were successful before and the other way around. But overall, no big improvement. But then we thought, like, why are we creating one rewrite? What about different rewrites? Because questions are complicated. Like there's normally not one statistic answering the question. There are a lot of statistics answering the question. So we did a multi-query rewrite. So just ask him to come up with multiple queries. So for example, which company had more revenue 2015 to 2020, Apple or Microsoft? And the large language model comes up with queries: revenue for Apple, revenue for Microsoft, and a comparison of both. So when you do the retrieval for each of those queries and then merge them together in the end, you have a lot of different aspects in your data to answer this question. And this really showed a big quality boost. So this improved our application a lot. Only a little bit smaller, a little bit slower, a little bit more expensive, really not too much, big quality improvement. Still, when we thought about it, we're still using a question to do a similarity search for gaining answers. And we experimented with a technique that's called HYDE. It's hypothetical document embeddings. And here the idea is, why not taking an answer to retrieve answers? Because it's based on semantic similarity and not on like a search. And this is what this technique does. So it asked a large language model to transform the query into some kind of fake answer. in this case fake statistic snippet that looks like other snippets from our data, it's potentially wrong. I have no idea if these numbers are correct. It doesn't matter. This snippet is just more similar to other snippets containing the real numbers, the real answer. This was the idea. Overall, we've seen a quality boost here as well. So it really improved. It changed the answers a lot. So here as well, some answers broke that were successful before and the other way around, but overall, a big quality improvement. So as these answers have changed a lot, why not just combine everything? It looks complicated, but I mean, most of it is in parallel, so it doesn't affect the system too much. Hide is a very slow technique. We could integrate it because we improved the latency too much with other techniques, so this is our reinvestment. Yeah, but this is where we ended up. A lot of retrievals that in combination produces really good answers. And so we could reach those metrics that are ready for production. So let's talk a little bit more about the model. So up to now, I talked a lot about retrieval. Of course, it makes sense because if you haven't retrieved the correct data, it doesn't make sense to generate an answer on it. But still, choosing the correct model is crucial as well. There's a lot of potential. So if you look at, this is a general comparison by artificial analysis. On the x-axis, you see the price. On the y-axis, you see the quality. And so there's a lot of pricing difference. And if you just compare two of them, like GPT-4 Omni as the default for most projects, and the Gemini Flash by Google, you could save 98% of your costs if the Gemini Flash model is suitable for your use case. And if you're interested in latency, especially important for real-time, real user interaction, well, you could use, for example, the Llama 70B model hosted on Cerebras. It's 27 times as fast as GPT-4 Omni. And let's have a look how this looks. There's a new summarizer. The 70B Llama model is already done. This is a real-time comparison, so the Omni model is still working. Let's see how much. Yeah, and now it's done. So this is the difference you can achieve just by changing the model. And here, with this comparison in this application context, no quality difference. So it's really the same. So which model is sufficient for you or for your use case? You need to test it. You need to try it out. Look at the current models, at the performance, test it. There's not really a one-fits-all. And the problem we've seen in projects like this is sometimes it's completely fine. Like you have a query with good retrievals, only need to summarize it or select the answer. A small model like 3.18b Llama model is completely fine, good results. But then there's the next request, the next query from a user. It's more complicated, more complex conclusion. It's not okay anymore. You need a bigger, you need a more sophisticated model. So there's no one-fits-all. Most of the times you need to just select the bigger one and the slower one. But still, I mean, we didn't need it at Statista because our metrics are good. We are ready for production. And now Ingo will tell you something about the business learnings we had.
Thank you, Matti. Yeah, indeed. We were obviously very happy with the work of Matti and also our internal engineers, and now had the confidence that we did not only have the proof of principle, but also production readiness. Obviously, it is still a way to go until you have a product. So what was good, we knew this kind of fancy engineering kind of local working prototype is doing a job, which is helpful, and it's working. But to come to a product also included a lot of work which was happening in parallel to Matti's work. We had to work on UX, obviously. We had to develop a go-to-market strategy, pricing, you know, all the stuff, right? Which makes a product much more beyond the technique. In the end, we launched ResearchAI. As you see here, it's always evolving, but that's pretty much still the UX you get. So you have the possibility to launch several queries. You get the answer, you get the links. So you see the essence of the early prototype still, but there's also some changes. You see, for instance, that we said we know our customers need quick understanding of the key facts of the findings. So reading through several lines of text is not always what the user experience expects. So we extracted key facts, tried to do some visualization because it also should be appealing. And that is what we actually launched. And we have launched it almost 5 months after we had production readiness. So you see there's a serious time gap between technical feasibility and market readiness. Some numbers to share. So what is our first experience from a business perspective? First of all, adoption. We are really happy that our customers appreciate the new service. I mean, they didn't ask for it. We tried it, we offered it, and now it's about finding out whether it really hits a nerve. It seems to do so. So among the paying customers, you see that the usage is rising over the past months quite significantly, and this is continuing to do so. We are also, from our sales colleagues and customer service colleagues, get the feedback that customers are really appreciating it. Second, we also see that users can work with the page. There's a low bounce rate, and the page seems to work and fulfill the expectations. And finally, also, there's another important aspect. We see that those customers who engage with ResearchAI tend to interact with more content on our platform, which is actually super valuable for us because I told you we have millions of statistics. A typical customer doesn't find the best statistic he or she is looking for. So whatever we can do to bring customers in contact with more statistics and the relevant statistics is doing a great job. And here again, ResearchAI seems to trigger a different user behavior compared to keyword search, which is good in our context. If we come back to the factual numbers regarding performance, quality, and latency, also since then we have done more iterations. We are now down to 14, 15 seconds in response time. Costs have decreased significantly, again, which was also important to roll it out and to offer it to a lot of customers, and quality has remained at a very high level. But as you know, the quality is an internal benchmark, which we did. We are perfectly aware that we don't have to compete against the quality expectations of our customers, but there's big fish out there that doing similar jobs, and we need to compete against them. So what we developed quite early, I think we are not doing it for 6 months, is a benchmark with the leading generative AI models, the public ones that we have. You know ChatGPT, you know all of them. I mean, that's no secret. And we applied the same quality metrics that we are applying to our metrics, also to them. And we are comparing how we are doing, right? Because if we are performing worse than those, then we have to work on it and need to understand why. And you see that research actually for the criteria we apply is performing very well. You also see that we need to adapt the quality metrics from time to time. You see the dip between September and October, for instance. That's due to a change in the quality metrics. So that's not a fair comparison over month. But I think you get the gist, right? So it's important for us to have confidence that we are delivering really good quality. Still, that is quality. Also regarding adoption, just to put it into context, I mean, we are really happy that we see a large take-up in user behavior here. But obviously, the dimensions are completely different. You see 3 billion with ChatGPT. Perplexity even, who's doing a great job on quality level, is increasing fast, but is a completely different and lower level of user adoption compared to ChatGPT. So the question is, so for us, is how to engage even more users. We know they are happy if they get in contact with the users, but the actual adoption numbers are still quite low. And if you remember how I started the talk, 66 to 80% of our traffic is organic, so coming from Google. Where do those people end? They end on the statistics. They don't end on ResearchAI. You don't Google for ResearchAI, right? You want to know the smartphone share of Nokia in 88 in this country or whatever. Not 88, 98 probably. So that is where users are typically landing. That's where 80% of our sessions are starting. And we now just launched the A/B test to bring ResearchAI onto this page. And the way we tweak your ResearchAI here is a bit different, as you see. There's no search bar, but we already know the context the user is in. So here we are trying an experiment where we say, if this is your context, this is a typical follow-up question, which leads you to more insights, right? And that's now the start of a long series of A/B testing to see how such an LLM model with all the capabilities can be made valuable for our users. On a macro level, there's also a lot of things changing. We now discussed the use case of customers coming to Statista using ResearchAI, which is nice. But there's also other ways that we experience over the past month which are taking up significantly in demand. And the other alternative is we see especially large companies, you see consultancy companies, media companies and so on, they are creating internal departments only focusing on leveraging the internal data set assets for their users. And they are also building LLMs. They are also applying RAG models and so on. And they are knocking at our door and saying, look, we'd love to integrate your insights into this very company-specific and tailored to our customer needs or employee needs solution. And that's a whole different business field, because here it's not our job to build an LLM, but to provide our data in a secure way to enable our customers to use our data. And then finally, there's also a third angle which is happening still. You see the adoption rates with ChatGPT, Perplexity, Gemini, and so on. Also, those models will only improve with better data. So there is an interest, obviously, for those providers to get exclusive data that others don't have, that they cannot crawl. And that is also a valid business model, right? You could also position your company as a company who is basically feeding exclusive data to large LLM providers. But that's also a very different business. So this is something we are testing very, very carefully. But users will in the end decide what the dominating party will be. So stay tuned for that. Good. And with that, I hand over to Bene for taking an even broader picture on our community.
Yeah. Thank you so much, Ingo. Let me close it up for you guys, as we are, I have like a lot of time now still left. That's awesome. Okay, so bringing it to the broader community. So as I said in the beginning, I was introducing both parties to each other, right? And this is basically the business model of TalentFormation. We are not someone who's like contracting or like a Vermittler or someone, but what we do is we do projects that are very, very sophisticated and that need a team of experts to tackle it. And we are steering or managing around this project as well to make it really work and selecting the team. And that is what we did here, right? So Ingo came to us and asked for someone that could potentially optimize this AI proof of concept. And I immediately knew that Matti would be the right person for that, and with his peers, the right team to tackle all of the issues, because it not only takes someone who can build an AI system, but also to have the infrastructure or know how to operate it and know how to optimize it and stuff like that, right? So there's a lot more than just building the system. And what also is important to us as TalentFormation is that we not only do such projects, but we also try to build products out of these projects, right? So one product was the product we optimized for Statista, but maybe there's something in there that can be a new product that you could also use for your AI projects, right? That you are building. And that is what we did here as well. And we found, or Matti and his team found a use case. He described it earlier. A use case that can be that everybody has, right? So choosing the model. Choosing the model is something that everybody needs to do in their systems. And there's no solution that is like one model is the best, right? So we saw that. So we need to really choose on a request level in this whole chain each request and optimize it for using the best model, which has the best quality, but also the lowest cost and the speed. And this could be an own product, right? So you could have a product that someone just integrates into their RAG system and then optimizes automatically which models should be used, so that you don't need to do that manually anymore. And that is what we built, right? Or what you built. So AI router was created, and that is this. Yeah, you can like small applause. And that is actually like a really, really cool product, because yeah, as I said, you can on a request level, on a module level, you can decide whether to boost the quality or to boost the speed. So you have like a little bit of options to configure the penalties or the boosting of the requests, and in the end, it will do the rest automatically. And for the customers who are already using it in their production system, it actually saves them around 82% of the costs automatically, just because integrating it. And that is what I want to close the presentation with. So you've seen a lot. You've seen the great project, ResearchAI, the great product that is built with a real valuable production AI use case. You've seen how you can optimize it, what the process behind that is. And what you can actually do is to also create a product out of that project. So yeah, I'm super happy with that project, with the whole thing. I would really, really love to do such thing again. And I'm happy for your questions. So yeah, stand up and thank you so much.
Thank you very much. And we have 4 minutes left for a couple of questions. So raise your hands if you have any questions. Please say your name, your title, and your question.
My name is Mark. I'm a product manager at Codecentric. First of all, thank you for this interesting presentation. Finally, a production case. I was waiting for that today. Really interesting. I have 2 questions. The first one is, what was your rollout plan? Did you roll out to 100% of the users or to a subset and then increased the user base subsequently? And the second question is, what were your considerations about pricing and what pricing did you end up with?
I think I can take those.
Yes.
Rollout. We, I think, applied quite a classical model. First, we tested it with internal users. We used the most critical ones, which is the researchers. We knew they will be skeptical. They will say this is never going to work. So this was the first iteration. It took us about 1.5 months to understand their feedback. Then there was a beta phase. At first, a closed beta. We have some customers who are with us for a long time. They have signed up for Customer Circle, and they were the first beta. Then an open beta where everybody could register. But you had to register in order to see the product, so you were perfectly aware what's happening. And once this public beta was also working, we launched it to all customers. The second question is about pricing. And pricing is a difficult one because we are still in the process. The first attempt, or the first positioning is a value-enhancing feature. So we said this feature increases the value of our product, which gives us a reason to justify yearly price increases, and it also will have a positive impact on net retention rate. That was how we started. And we fenced it, so you have to sign up, for instance. Everybody can use the product, but you have to sign up. So at least we get a lead, right? But it's limited in the number of requests you can, because it does cost money for us if you use it. Now the pricing will change next year, and I cannot go into details, but basically we will apply a consumption-based pricing, yeah, where we have different products where we can upsell customers, and if you have very low frequency usage of ResearchAI, you can use the most basic product, and if you want to use it on a regular basis as a company, then you pay the premium products.
Thank you very much. Next question. Front row, I'm coming. Please say your name, your title, and your question.
Hi, I'm David. I'm a product owner at Vorwerk. And I was wondering, since most of your traffic is coming from organic search, how afraid are you currently about the recent changes in search traffic? Or do you see a significant decrease in search traffic over the last years?
No, interestingly not. We back in 2023, that was actually quite a concern. It was a scenario we prepared for. Until now, it's stable. We have rather stable SEO traffic, and it's fluctuating as we know it. Like after Trump's election, we had a huge peak, 40% more traffic than before. So there's still the patterns we know from before. Until now, public general purpose or GPT models don't steal the traffic from SEO. It's still on almost the same level.
Thank you very much. And that's it from the learnings from Statista's generative AI journey. Thank you very much, Benedikt Stemmildt, Matthias Lau, and Ingo Schellhammer.